Hello everyone, welcome back to my channel Monica Math Classes. Today we will begin a new topic named coordinate geometry. But before we begin, I would like each one of you to like and subscribe the channel and also refer to your friends and relatives so that everyone can be benefited. So let's start with today's class. It's a very interesting topic which we will begin today. It's something related to geometry and algebra both together. So this is something you are doing from previous years, but today we will recall first all the important components of coordinate. Okay, so let's begin. So this is your coordinate axis. So it has horizontal axis over here. Okay, this is horizontal x-axis. Here on the right side, all are positive, and on the left side, all are negative. So remember this. Okay, so this is just a number line that you have done. Okay, and here on the vertical line, which is called as y-axis, up we have all positive and down we have all negative numbers. And you can see that all the numbers are arranged in that. Okay, and all the numbers from 0 are at equal distances, like the way you do it in a number line, exactly the same way. So 0 to 1, 1 to 2, 2 to 3, all should be same. Okay, and where these two axes, where these two lines intersect, that is called origin, and its coordinates are always 0, 0. Another very important part is that both the axes x and y, it divides this full plane into 4 quadrants. So first is your first quadrant, and it has positive and positive points. Means x and y both are positive. You can see on this side, this is positive and this is positive. So based on that, you have positive and positive. Second one is our second quadrant, where your x is negative and y is positive. So minus plus. Third quadrant is minus and minus because x is also negative and y is also negative in this region. And the last, fourth quadrant. So your x is positive in this region, but y is negative. So based on that, you are going to locate your all the coordinates. So another very important part is how you're going to write the coordinates. It should be in this form. Okay, so x and y, it always should be written in ordered pair. This is called ordered pair. It has to be in brackets. So first always is your x and the second is your y. So if I give you, for instance, if I ask you, can you locate 4, 3? How we are going to locate this on this plane, on this coordinate plane? So first, always it is x. So you will go, and it is positive. So you will go this side. So this is your x, okay? And then the y is 3. So you will go up and mark where it should be 3. So this is here, this point, okay? So this is your point 4, 3. And you can name it with some letter also in it. Suppose if I give you something like -2, 4, how we are going to locate this? So first is your x, which is negative. So you will go towards this side, left side. This is -2. Then 4, which is positive, on which is should be on y-axis. So you should go up and down. It's a positive, so you should go up. So you will go up, and this is your point. So this is how you should coordinate. So -2, 4. So this is your coordinate. Okay. So understand, it is important that when you mark in the beginning, that if you can locate with the help of some dotted line, which helps you to understand better. So I'm just making a dotted line again. So this is your point, and here 4, 3. I hope you have understood. These are the very important and foundation elements, okay, concepts for this coordinates. So quadrants, how to write these coordinates in ordered pair, and it has to be first x and then y. Okay, so moving forward now, so important part is what are the practical applications of coordinates. So practical application, I would say that especially in movies, you must have heard about coordinates when the plane is in the sky or submarine is under the sea. So navigates whenever they always ask for the coordinates. So it is a very important part that everyone should understand that what do you mean by coordinates? Okay, so again, as I said, it's an very interesting branch of mathematics because here you deal with algebra and geometry together. It is a good, mix of both, combination of both. So once you've understood, it becomes very easy. And formula inside this topic, which we are going to begin, that's also something interesting. So first of all, understand this is an algebraic tool for studying geometry of figures, and it also helps us to study geometry using algebra. So as I said, it's a combination of both of them. So if you've understood one thing, it's very easy to understand this branch of mathematics. So it is widely applied in engineering, art, physics, navigation, and seismology. So the very important part in this particular topic is your distance formula. Okay, so what is distance formula? The distance formula means suppose you have 2 points, P and Q, and you have to find out the distance between these two. Suppose P is this and Q is this point. Okay, and you have to find out the distance between these two. Suppose if I say x1, y1 is the coordinate for P and Q is x2, y2. How do you find out the distance between these 2 points? So this is the formula. Root x2 minus x1 whole square plus y2 minus y1 whole square. So you have to remember it. Okay. So once you have remembered, every time you have to use the same. Then you will learn it by heart. Okay. So another important aspect is distance of a point from origin is this. How is it possible? Let me just draw it. Suppose these two lines intersect at this point and you know the coordinates are 0, 0. Suppose you have this one point P whose coordinates are x and y. So again, you understood? So that when it is x2 minus x1 whole square, when you put the value in this, so what it becomes? It becomes x2, which is x minus 0 whole square plus y minus 0 whole square. Ultimately, it becomes this only, root x square plus y square, right? So when you apply the same thing on the original formula, you get exactly the same thing. So you don't need to remember it, but understand because one of the coordinates becomes 0, 0. So obviously it will come as this x square plus y square. Okay. So one important part is this. Now, after this, if you remember now all the things which you have learned in 1 second. In this part of triangle, do you remember all your points what you have learned in seventh, eighth, and ninth, or in the middle school? How to the properties of rectangle, triangle, and all of them. That's very easy to understand. Okay, so if they ask you, suppose these points form a triangle, how do you prove it? Do you remember? If any of the three sides are given, this is the properties of the sides of a triangle. If any of the sides are given, how do you know that they will form a triangle or not? So to start with any of the question, you should know the property first. Okay. So once you know the property, then only you can move forward, right? So to form a triangle, the sum of two sides should be greater than the third side. Okay, so first of all, we need to find out what is the distance between all of them. Okay, so we can assume that first coordinate be P, second be Q, and the third be R. Okay, so we will find out the distance between all those three. So for the first is PQ. Okay, so you have to find out the distance between PQ first. Okay, then you have to find out the distance between QR. And then you have to find out the distance between RP or PR. Okay. So once you have understood, you will find out something that am I able to find out the distance, and then am I able to find out that is the distance between the two sides is same or not. So let's see. So PQ. So the first is your X1, Y1, and the second is your X2, Y2. Remember, you have to rename it, okay, to understand it better. So first advice is that always you write the formula. You will never forget them, okay? So let's begin. X2 minus X1. What is X2 for me? Minus 2. What is Y1 for X1 for me? 3. So X2 minus X1 whole square. Now next, y2 minus 3 minus 2 whole square. So what it becomes? It becomes minus 5 whole square. And for second, it becomes minus 5 whole square. Then next, I got 25 plus 25 and it becomes root 50. So I'll keep it like this for the time being. Now let's see for the next QR. We have to find out the distance between this Q and R, these 2 points. So how much is the side now in this case? So x2 minus x1. 2 minus of minus 2, a minus x1. So it becomes plus 2. Then second y2 minus y1, it becomes plus 3. So what it becomes? It becomes 4 square plus 9 square. It becomes 16 plus 1 second. This is the same mistake I did. What the children do? I did 3 plus 3, 9, which is 6 by mistake. Okay, so 3 plus 3 is 6, 6 squared, so it becomes 36. Now square root of 16 plus 36, it becomes 52. You'll keep it like this. Now square root of RP. Now R and P, 2, 3 and 3, 2. Okay, x2 is R2. Okay, so x2, 2 minus 3. And then we have y2 minus y1, which is 3 minus 2. What it becomes? It becomes minus 1 whole square plus 3 minus 2, which is 1 square. And square root of minus 1 whole square, it becomes 1. And this becomes 1. So it becomes square root of 2. Okay. Now, in case, okay, you want to go further, what you can do here over here, you can further find out the square root using a calculator, or if you know the square root by long division method, you can calculate. So for this one, it will come near about 7.07. In this case, it will come as 7.21. And this one, you know that it is 1.414. Okay. So now you have to check whether they will form a triangle or not. So for that, you have to use this property, sum of two sides should be greater than the third side. Should be greater than the third side. Now, if I see, I have to check whether it is. So you can check the sum of these two. Is it greater than the third side? Answer is yes. When you take these two, is it greater than the third side? Answer is yes. So randomly, any of the two sides, you take possibility for all the three and it is coming greater than the third side. So answer is yes. It is forming a rectangle. So the question is, what it form a triangle? What type of triangle? Suppose your second part is yes, it forms a triangle. So your first part is done. Yes, it forms a triangle because all the possibilities we have chosen is correct. Okay, now what type of triangle? Now for the second part, what type of triangle it is? How do you decide? So I have to go back again and check. Is something related to Pythagoras theorem? Do you remember the converse of Pythagoras theorem? The sum of the square of two sides should be greater than the third side. If it is so, the answer is correct. Okay. So if I see PQ and if I see take this RP, okay, root 50 and root 2. If I square them, add them and make a square and make it equal to QR, is it the same? If I add, answer is yes, root 50 plus root 2, if I add, it becomes root 52, exactly the same. So if I do PQ square plus RP square, is it equal to QR square? Let me check. Is it equal to this? So PQ is root 50 and RP is square root of 2. And for this, it is root 52, which we have calculated. So 50 plus 2 is equal to 52. So it is exactly the same. So you will write here by converse of Pythagoras theorem. What is 90 degree in this? What is 90 degree in this? So by converse of Pythagoras theorem, this is a right angle triangle. Which is right angle at P. Which is right angle at P. Okay. So something you will get a triangle like this. Okay. So you will make this is at P and you can make Q and R. And the distance also it's visible that it is coming, the distance between this is PQ and RP is coming as root 52 and this is coming as root 2. Okay, I hope this is clear, interesting. So with the help of coordinate geometry also you can prove. But you should know the properties of square, triangle, rectangles, all of them. Then only you can apply the distance formula, the distance between the 2 points. Let's move forward. Are we clear with this? Okay, let's see ahead. Okay, now you have another example where you have to show that these are the vertices of a square. Now, in a square, what is important? What is important in a square? So in a square, I think everybody knows the properties of a square regarding sides. All the sides are same. All sides are equal and both the diagonals are equal. So that means we have to show both in this. Okay. So probably you can give name to it. What name you want to give? Generally we put ABCD. So let's name it as ABCD. Okay. So A is 1, comma 7. B is 4, comma 2. C is minus 1, comma minus 1. And D is minus 4, comma 4. Let's see this one also. So as I said, if you know the properties, the things become very easy. You know that this is my plan and I'm going to execute it and check if it is same or not, right? So we have to prove this. So I will check the distance between all of them. So the distance between all the points. Okay, so let's take one by one. So find out the distance between AB first. So AB is your x2 minus x1 whole square. Again, x2 is your 4, 4 minus 1 whole square, and y2 is how much? 2 minus 7 whole square. So what it become? It become 4 minus 1, 3, and 2 minus 7 become minus 5. So what it becomes? It becomes 9 plus 25, which is equal to 34. So this is my AB. Next, we are going to calculate for BC. So for this, we have x2 minus x1. Okay, so here my x2 will be minus 1 minus 4 whole square and y2 is minus 1 minus 2 whole square. So what it becomes? It becomes this minus 5 whole square plus it becomes minus 3 whole square and it becomes exactly, do you see that you are getting exactly the same kind of numbers, 25 plus 9, which is equal to so far square root of 34. Exactly, we are getting the same thing, yeah? Now, after AB, BC, now next is CD. So, CD, C is my x1, y1 and D is my x2, y2. So, x2 minus x1. So, it becomes minus 4 minus minus plus. So, it becomes plus 1. Y2 minus y1. So, it becomes plus 1 whole square. So, it becomes again minus 3 whole square and this becomes 5 whole square. And then it becomes 9 plus 25, which becomes square root of 34. So far, for all the three sides, we're getting the same distance. Now let's see for DA. Now for DA, x2. D is my x1, y1 and A is my x2, y2. So x2 minus x1. So it is DA. So 1 minus of minus, it becomes plus, and y2, it becomes 7 minus 4. So what it becomes again, it becomes 5 plus 3 whole square, which is equal to 25 plus 9, which is equal to square root of 34. So see, you got all the three sides with the same distance. That means one thing is clear, that all sides are same. But when all sides are same or equal, there are two possibilities. Either it can be a square or a rhombus. So far, we don't know. We have not decided yet. To prove a square, we have to prove yet the diagonals are also equal. Okay, so we have to prove that as well. So we will prove our diagonals now. Okay, I hope you know the diagonals when you join the opposites points. So AC is my first diagonal. Okay, so for AC, x2 minus x1. So x2 is my minus and minus 1, and y2 is how much? Minus 1 and minus 7. So it becomes minus 2 whole square, and it becomes minus 8 whole square. What it becomes? 4 plus 64, which is equal to square root of 68. So one of the diagonal, I got 68. Let's see if my another diagonal BD is also exactly the same. So BD is this. So B is my x1, y1 and D is my x2, y2. So square root of, okay, so x2 minus 4 minus 4. X2 minus x1 plus y2 minus y1. Y2 is 4 minus 2. So what it become? Minus 8 whole square and plus 2 whole square. I think exactly the same kind of figures you're getting. 64 plus 4. So now this root 68, both the diagonals are also same. So answer is, you have showed, answer is yes, it's a square. And what's the reason for it? Because all the sides are equal and both the diagonals are also equal. That's why it's a square. I hope you have understood that how we are proving it using distance formula. Distance formula is very, very important in proving such kind of questions. And one more very important part is that you know the properties of triangles, squares, rectangles. Then only you could place the things correctly. So again, I would say practice, practice, and practice till the time you become perfect and permanent in your learning. So I wish each one of you happy learning and keep practicing. Okay, rise and shine. Bye, everybody.